Dear students, how are you? Hopefully you are well. This is Amit Saha, lecturer, Department of Mathematics, Milestone College. Today our discussion topic is matrix. This is your chapter 1 and today we are going to discuss about 3 important definitions, that is idempotent matrix, involuntary matrix, nilpotent matrix, and also we are going to solve some operation on multiplication, and this part is very important for your exam as well as your board exams too, because we are trying to solve our multiplication in a different way. Hopefully you will enjoy the lecture. Okay, let's start our today's lecture. Dear students, how are you? So according to our lesson plan, today we are going to discuss about 3 definitions, that is involuntary matrix, idempotent matrix and nilpotent matrix, and we are going for some operations, and I will show you why the operation actually work like this way. However, today's lecture is depending on the matrix and determinant, especially we are talk about the matrices. Okay, so our first part is idempotent matrix. So what's the definition of idempotent matrix is? The definition will become after. First of all, what actually the idempotent matrix is? Idempotent matrix, if a square matrix, should be A, or if a matrix A, if it is satisfies A square equal to A, then we can say this is the idempotent matrix. So if any square matrix A is said to be idempotent if A square equal to A, but the fact is only A square equals to A, on that time it is idempotent, or the another explanation can be given. Here it can be said that actually what does mean by A square equals to A? Actually the meaning of A square is equals to A into A. That means if we multiply 2 square matrix and we get that same matrix back, then we can say that this is the idempotent matrix. Okay, move on to our second part, that is if it is A cube, if we are going for A cube, then what will be happened? A cube, when we are thinking, then it can be A square into A. Since we have already think that A square equals to A, then we can say that it should be A into A. That means A into A, and A into A means actually A. Similarly, if we are going for A to the power 4, on that time we get actually A square whole square. That means A square, because A square equals to A, and that is actually A. So if we are going for A square, A3, A to the power 4 or something like that, finally we get a value that is A to the power n. The A to the power n is also A, where n is belongs to the positive integer. So actually our definition of the idempotent matrix should be that if any square matrix A, then this matrix can be the idempotent matrix if A to the power n equals to A, where n belongs to I positive or integer or positive integers. So our definition of idempotent matrix is what? A matrix or I square matrix A can be idempotent if A square equals to A. If you write, then okay, or you may write that A to the power n equal to A, where n belongs to I positive or positive integers. That is called the idempotent matrix. Okay, move on to our very important matrix, that is involuntary matrix. At the case of involuntary matrix, it is very similar to the idempotent matrix. Idempotent matrix was saying to us that this is also a square matrix. Suppose a square matrix A is said to be idempotent if what? A square equals to I. So a matrix or a square matrix A is said to be involuntary if A square equals to I. So at the case of involuntary, what? A square equals to I. So move on to the parts what we can get. If we are thinking that a to the power 3, then we get actually a square equals to a, where we know a square equals to I, and identity matrix into a. I means the identity matrix or unit matrix. If we multiply anything with identity, then we get that same matrix back. Okay, again, if we are going for a to the power 4, then we get actually a square to the power whole square. So it should be I square to the power whole square, that is I. If we are going for a to the power 5, we will get actually a. If we are thinking that it is for 6, then it will be I. So here a to the power 6 equal I, a to the power 5 equal a to the power 4 equal I, a to the power 3 equal a. What does actually it means? It means that at the case of even power, we will get I, but at the case of odd power, we will get actually a. So our involuntary matrix definition should be actually a to the power n is equals to, two things can be given. One is we may get a or we may get I. When a can be found? If it is or the n is odd. If n is odd. And when we will get R? If n is even. So if we are precisely thinking that what actually the involuntary matrix is, then we have to say that a matrix should be involuntary if what? If our square matrix A satisfies this condition, where a to the power n equals to a when n is odd, and a to the power n equals to I if n is even. That is called the involuntary matrix. Okay, now we move on to our last part, that is what is actually the nilpotent matrix is. At the case of nilpotent matrix, it is the same part that we will get a square matrix again, a square matrix A, a square matrix A. Suppose we are thinking A is a square matrix where a to the power n equals 0, a to the power n equals 0, but a to the power n minus 1 is not equal 0. A to the power n equals 0, but a to the power n minus 1 is not equal 0, where n is the index of this, where n is the index of this matrix. Okay, where n is the index of the matrix. Maybe one question arises in your mind, why I am thinking for this, what is n, what we have to do. Actually, if any matrix is given to you, suppose one matrix is given and we have to think for, suppose A is given and A is, suppose we are thinking 0 0 0 1. Okay, this one matrix is given. Now we have to consider A square first. If A square equals to 0, then 2 is our index. But it can be like this, that for A square it is not 0. If A square it is not 0, then we have to go for the third part, that is A cube, where A cube should be A squaring into A. If it is 0, then 3 is our index. If it is not 0, then we have to go for again, that is A to the power 4. If it is not 0, then again we have to multiply. So when we are going for the matrix multiply for actually again and again, then we will get at one time that A to the power something is equals to 0. Suppose at the time of A to the power n, it should be 0. So our n would be the index for that matrix. Clear? So here actually n is the index of this matrix. But one thing what I wanted to mention from here, that is what is actually the 0. Here 0 is the 0 matrix. 0 matrix. What is 0 matrix? if every element or every entry of a matrix is 0, that is called a 0 matrix. So one example can be like this. It is a 2 by 2 matrix where all entries are 0. So this 0 means the 0 matrix. Okay, and one thing I wanted to actually show you that how we can memorize or distinguish these two matrices, because these two are very similar. For this matrix it is A square equals to A, but for this matrix A square equals to I is found. So at these two the matrix we can distinguish this matrix by a formula, that is ID or ID card. What ID? It is idempotent matrix where it has a ID, and ID means one name. Your ID means your name, and name must be the unsensed. That means A squared should be A. So the distinguish these two parties, it is idempotent matrix. That means it has the ID which ID is not sensible. That means if we square, cube or to the power 4 or something like that, you will get that matrix back. That is called, the matrix is named idempotent matrix. But if at the case of involuntary matrix, it is actually I. So this is the basic difference between these two matrices. Clear? Okay, dear students, here actually we have observed that some example of these matrices. Move on to the operation part. At the case of operation part, we are focusing on first the addition and subtraction. Suppose two matrix is A, B, C, D. This is the A matrix, and M, N, L, O, this is the what? B matrix. If we add these two matrix, then what will be happened? On that time actually the first part and its first part, that is the order, its order is 1 1, its order is 1 1, so it should be added. So it can be written as A plus M. Here the position of it is first row second column, it is also first row second column, so add these two. At the case of this is our second row versus first column, it is also the same thing, so it should be C plus N, and here it is second row second column, this is also second row second column, that's why these two should be added. That's the addition. At the case of subtraction, everything will be same, just at the place of plus it should be exactly minus, at the place of plus it should be minus. That is the subtraction of these two matrices. Sometimes the question maybe comes like this way, that if there is given suppose A is given, okay, and we have to find suppose 5A. What does it means actually 5A? We have to feel it. Actually 5 is multiply with A. 5 is multiply with A, and if we are writing this, that 5 into what? A, B, C, D. Dear students, it's a very important part, and we move on to our multiplication part also. Here, so here we are going for just multiply every entry into 5. So every entry should be multiplied with 5. So it can be what? 5A, 5B, 5C, 5D. This is the basic multiplication of the matrix part. And now we are just think that how our multiplication works and why the multiplication should be like this way. Now we are going to discuss about this fact. So now it is matrix multiplication. Matrix multiplication. Okay. Suppose we consider two matrix. A is suppose A, B, C, D, and B is a matrix, suppose X and Y. First thing, that when two matrix is multiplicable, or what's the condition to be two matrix multiplicable, that is if the first matrix or the column of the first matrix and row of the second matrix are equal, then we can say these two matrices are multiplicable. It's a very important thing. Suppose example part, at the objective part we have seen that that what should be the AB equal what. On the time you are going for just multiplication, and after that you will got no answer, because you didn't know what's the main fact or what is the main objective of the multiplication. At the case of multiplication, there first or column of the first matrix is equals to row of the second matrix must have to be same. You have to check it first, then you have to go for the multiplication. Okay, this is the first and foremost rules for you at the case of multiplication. So now check it, that what's the column. So here is two column and here we get two rows. Since we get two columns and two rows for second matrix, then we can say yes, this matrix is multiplicable. Now my question is, if these two matrices are multiplicable, then how the question or how the matrix multiplication works? Okay, when I'm thinking for that how it works, on that time I wanted to go for the vector part. Okay, I wanted to give the basic idea of a vector, okay? Because this is very important for to understand the multiplication. Suppose we are thinking in a two-dimension part. Suppose this is our y-axis, it is our z-axis. At the case of vector, if it is a matrix or a vector, it is b vector, then we can say it should be ai plus bj. Okay, that means it has actually a standard form, and that form can be written as like this way also. That is you are very familiar to that part, that is xi plus yj. That is the actually standard form of vector, where x is the identity which lie on the x-axis and y is the identity which lie on the y-axis. But why I am writing it here? Look at the board. It actually, we are thinking when we are going for the multiplication, this is actually the I column. Sorry, this actually the I column, I. Okay, and this actually the z column. This is the ith column and this is the zth column, and this is the x and y. Okay, so if we just use this formula into here, then we get the multiplication within a very easy way. How? Just look at the board. Here, if we thinking for our x should be remain same as before, but at the case of I, we can what? Here is the I column is given. I column is a c plus there is also y, and j column means what is this? That is b d. Clear? Now just we are found 5a at just previous part. When I was talking about 5 is multiply with a matrix, that means every entries of the matrix multiply with 5, isn't it? That means our this matrix should be like this way, that xa xc plus yb yd, and that means actually we can write xa xc yb yd. Okay, maybe you have already know that matrix multiplication is this row, this column, this row, this column. Actually that is come after a huge part. It is come with doing some a huge process after it is coming. Okay, but it comes which way? It comes like this way, and this is the main way to find out the multiplication. Here it is xa plus by, then cx plus dy. This is the multiplication of these two matrices. Maybe one question is arising in your mind. So here is 2 by 2 matrix. It was what? 1 column and 2 row 1 column, so it is 2 into 1 matrix. So what about 2 by 2 and 2 by 2? We have to see the example of it. Okay, don't worry, I will go for that. Just a minute. So here I am just writing 2 matrices. So I was talk about that this is our ith column, this is our zth column, but it actually we are thinking for 1 by 1. We are thinking for it first. Okay, and here we are thinking that this is our x and this is our y. So what was our formula? Our formula was I into x plus j into y, isn't it? So if our formula is this, then how we can go for this calculation? Okay, here this is our I, so I is a, b, and multiply with e because e is our x. Okay, plus what? J. Okay, j means what? This column, that is c d. Okay, c d is multiply with z. After doing this, we have to take a space. We have to take a space because one part or one calculation has already done. So now we are going for the another calculation. That's why we have to go for the space. And when we are going for the space, then this part is move on to, this will be our x and this will be our y, but this is fixed, I and j. Okay, this is fixed. So at the case of this, what we can write? We can write that I into x. So I is what? A, b is our I. Okay, and what is x? At the case of this, x is f plus j. What is j? This is j. So c d is multiply with s. Now we are just multiplying. If we multiplying, what we will get? A e, then it should be b e. Exactly, we are going for direct calculation. Then cz plus dz. Now take a space. Then it should be af plus cs bf plus ds. Okay, this is the way, this is the genuine way to multiplication, or how can we actually multiply two matrices. Okay, now my question is, if this is the genuine way to multiply, then how can I do it in our exam hall? Because there is no time available in our hand. So how can I go for that? Okay, for that reason I wanted to go for again one example to go for the multiplication part, and that's why I am going for the actually example of the idempotent matrix first. What was our idempotent matrix example? That was 2 1 minus 2 1. Have you remember 2 1 minus 2 1 minus 1? That was our what? That was our the example of the idempotent matrix. Now we are actually doing two things at a time. What? One thing we are trying to show how the multiplication works. It is the number one thing. Number two thing is what? We will go for the proof of the idempotent matrix. That's why we are going for a square equals to a. If a square equals to a has been found, then we can say this is the idempotent matrix. Okay, now move on to our lectures. Here we have to find what? A square. What is a square? A square means a into a. Okay, now my question is, what is a? A is 2 1 minus 2 minus 1, and a is also same 2 1 minus 2 minus 1. Now we move on to our multiplication part. We move on to our multiplication. Okay, now this is the rows actually made by me. Okay, and the concept has come from our main matrix. Okay, that is, we will think always by column. Always we will think column wise. No row should be count in our head. Just there is no row in the matrix. Forget about the row. Why? Because we will think for the only column. So here is column and here is also the column, but this is I and Z column, so it should be the what? Fixed part. But here we are calculating one by one, isn't it? We are calculating one by one. That means 2 should be multiplied with ith column. So directly we can write it here, the 2 minus 2. Just write the first column as usual, then multiply it with 2. Okay, now take a plus sign, then write this column 1 minus 1, and it should be multiplied with what? Minus 2. We are talking about, we will always think about the column, we will always thinking about the column. So these 2 column work is done and one part has already done. At this column, which is exist or which is the remaining part, that is minus 2, so we have to multiply for minus 2. Look at the board very carefully. Just write the column directly, then multiply with first entry of this. Complete, take a plus, then write second column and multiply with second part of this first column. Then again write it 2 minus 2, write the first column. And now since our work has already done, that's why we take a space. Since our work has already done, that's why we are taking a space. Now this should be multiplied with what? Can you tell me? This multiply with this, because we will now thinking for this column, and the first entry of this column is this, so it should be multiplied with this column. So it should be 1 1 plus, again write our similar or same column, that is 1 minus 1, and it should be multiplied with the remaining part minus 1. My dear students, if you understand the process, then every multiplication of this matrix chapter will be very easy for you. Just will think for the column, how this column is writing here, then multiply with first entry of that, plus this will be writing here, then it should be multiplied with this. Now since our work has already done, take a space, go for this is writing, then the first entry will be multiplied, plus this multiply with this. Clear? Now just calculation, and I know that calculation is very easier for you. If we calculate 2 into 2 4 minus 2, that is 2. 2 into 2 minus 4 and plus 2, it should be minus 2. 2 into 1 2 minus 1, that is 1, and minus 2 and minus 2 and plus 1, that is minus 1. Look at our first part, what it was. It was the exactly a. So after squaring this matrix, if we get same matrix back, then this matrix is nothing but the idempotent matrix, what our definition says. So we can say yes, this is the idempotent matrix. Clear? So this is the idempotent matrix part. Now move on to our second part, that is the example of involuntary matrix, and that is 2 3 minus 1 minus 2. 2 3 minus 1 minus 2. I was written this example in your definition part, isn't it? 2 3 minus 1 minus 2. It is the example of the what? Involuntary matrix. Now we will do two things. What our involuntary matrix said, what? Can you remember this? Our involuntary matrix says that A square must be I, isn't it? A square must be I. If A square is I, then what we have to do? A square, that means A into A. So we have to multiply these two matrices, isn't it? What we have to multiply? Here is 2 minus 1, 2 minus 1, 3 minus 2, again 2 minus 1, 3 minus 2. Okay, this is actually two matrices. Now multiplication part, I was talking about these are ith row and this is the z column, and this is our x of first column and this is our y of our first column. So what we have to do, we have to multiply this column with this plus this column with this. Now so 2 and minus 1 should be multiplied with what? Should be multiplied with, tell me, exactly 2 plus what we have to write? We have to write 3 and minus 2, that is this column must be multiplied with what? Tell me, exactly minus 1. Thank you, minus 1. Is it very difficult? I don't think so. We are thinking about column, and this was ith row, this was zth column, and ith row must be multiplied with this, zth is multiplied with this, complete. So if it is first complete, then take a space, go for the same part again. That is 2 minus 1. 2 minus 1 is multiplied with what? This is, now we are thinking for this column, and we will multiply with 3 plus, then what we have to write? 3 minus 2 is multiplied with minus 2. Dear students, I think you can understand how we actually operate. If we can understand now calculation part, 2 into 2 4, 4 minus 3 it should be 1, minus 2 plus 2 0, 6 minus 6 0, minus 3 plus 4 1. So this is nothing but an identity matrix, isn't it? That means we can say it is I. You may write it here I 2 by 2, or you may write it I2, because it means actually what? I 2 by 2, that means 2 by 2 square matrix, and I 2 by 2 means this. And what about I 3 by 3? I 3 by 3 means what? I 3 by 3, that means there is 3 row and 3 columns. Just our principal diagonal, write it 1 and give 0. Then this is the what? I 3 3 matrix is here. Now we have already completed our multiplication part, and one example I have to do, since this is our in our lecture already. It's a huge lecture for you, just give me some time. Dear students, I know maybe it's going to be a huge lecture for you, but this is the last math what we are going for, and this math is very important for your exam too. However, now we are going for A, B. It is both two are actually 3 by 3 matrix, and now we are trying to solve 2 by 2 matrices. How we can solve this? Okay, suppose this was our x. I'm giving and marking here, that is this was our x, isn't it? Sorry, this was our I, and this should be our z, and this should be our k. And at the case of this part, this was our x, this was our y, and that was our z. That means we are going forward this formula, xi plus yj plus zk. Okay, now maybe one thing is arised in your mind that, sir, we are going for matrix, but why we are come from the vectors? If we are thinking the determinant in the 3-dimensional part, then it's a very interesting part. I will discuss about the determinant after some part, or after some lectures. However, we are going for this part first. So our first column is this. First column is multiplied with 1. First thing first. 3 minus 2 minus 1 is multiplied with what? Is multiplied with 1. So 1 should be multiplied plus. Now our second column is what? Minus 4 1 minus 1. This should be multiplied with what? We are thinking always column wise, so it should be multiplied with 2. So 2. Now take plus and plus, then we get what? 2 0 and 1. 2 0 and 1, and this 2 0 and 1 multiply with what? we have already 2 things complete. Now we are multiplying with 3. Okay, now since our total part has complete, take a exactly space. If we take, then it will be 3 minus 2 minus 1. It should be multiplied with what? Now we are going for this column, so this is the first entry, so it should multiply with 2. Plus should be here. Now 4 minus 1 1, sorry, minus 4 1 minus 1, it should be multiplied with what? It should be multiplied with 5. Now plus, so 201 201 201 should be multiplied with what? 7. Okay, now move on to a third and last part. Why? Because there is another column is there. Since another column is there, so again minus 3 minus 2, sorry, 3 minus 2 minus 1, it should be multiplied with, now we are moving on this column and this is the first part, so multiply with first. Take a plus, write it here, minus 4 1 minus 1, multiply with minus 4 and take a plus. Okay, it should be going for this color so that you can recognize it very easily. And now it should be 201 should be multiplied with what? Multiply with last part, that is minus 5. Just calculate it and get answer. If we calculate it, then we'll get what? We'll get 3 minus 4 plus 6. So 6 and 3 9, 9 minus 8, it should be 1. Minus 2 and 2, it should be 0. Minus 1 minus 2, 3 plus 3, that is also 0. 6 minus 20, 24, so 0. Minus 4 5, 0, should be 1. Minus 2 minus 5, 0. Minus 6 16 10, 0. Minus 7 plus 4 minus 4, 0. Minus plus 2 plus 4 minus 5, 1. So we get a identity or I3 part. We get an I3 part. So this is the question number 17, where we had to actually prove AB is equals to BA is equals to I3. I have already found AB equals to I3. Now it's your work. BA equals to I. What you have to do, just B should become here and A should be go there. So on that time it will be what? Our I is a K, so it should be fixed, and here we will work for X, Y and Z. So your work is BA equals to I3. Is this correct or not? Dear students, I know it's a very big lecture for you. Just split it down and watch this lecture separately so that you can understand all of the parts, but I am just try to give you more and more information. Hopefully this lecture is very important and effective for your upcoming studies. Thank you very much. Keep remain with your math practice. Thank you very much.